How y'all doing? Well, I'm back here again, and today I'm going to attempt, attempt is a good word, attempt to demonstrate to you how you can do a object-oriented programming approach in Go. Now, Go's not does not have a lot of the formal language features that languages like Java or C Sharp or even PHP have when it comes to doing object-oriented programming. You can get something similar, but not quite to the extent you can in those other languages. And I'm going to demonstrate to you as best as I can a example of that. So I have a empty file here, and this is not gonna be like an explanation of what object-oriented programming is. If I start throwing out terms like inheritance and uh, polymorphism, I'm going to assume you understand what this means. If you don't, go look up a tutorial about object-oriented programming. They're all over the place. So I'm going to start with I'm going to demonstrate this using the concept of bank accounts. And we're going to start with a basic bank account. So I'm going to define a struct here. It's called bank account. Which is a struct. And if you recall, in object-oriented programming, typically you have classes, and classes define both the shape of your data and the behavior that data has. Now, Go does not have classes, so the best thing you can do to emulate what a class is you create a struct which will take care of the shape of your data part, and then you use the receiver syntax that you can do with function definitions to attach behavior to those types, which is essentially emulating what a class does as best as you can in Go anyway. So our bank account's going to have two properties. This is going to have an owner string, and I don't think I'm actually going to use it in this example. And we're going to have a balance that's a float. Now you'll notice I am not exporting the balance. That's not technically important for this example because we're not ever going to be using it in a context where I wouldn't be able to see it anyway. But it's a common thing in object-oriented programming that you want to hide certain details about your type because you want to hide it behind things like methods so that you can control how someone can interact. And this makes sense for a bank account. You don't want someone to just be able to access and change the balance willy-nilly. You probably want to put it behind some kind of rules, which is what we're going to do right now. So we're going to implement three methods onto this type. Since our balance is hidden and not exported, we still want to be able to check what the balance is. So we're going to create what is often called in other object-oriented languages called a getter, which is a method that will return a hidden property from our struct. In other languages, this could technically be, it could be returning anything. It doesn't necessarily have to be a property. It could be like a calculated value thing. But oftentimes it's just used to get access to a property on a class that we can't access, or in this case, a property on our struct that's not exported. So I'm going to have func BA for bank account, and I'm attaching this to the bank account, and I'm just going to call it balance. It's going to return a float 64, and it's just going to return BA.balance like that. So that way, somebody using our code can still check what the balance is without being able to directly interact with it. Now, what's the two very basic things you generally do with a bank account? Well, you want to put money into it and you want to take money out of it. Okay? So the first thing we're going to do is let somebody put money into it. So I'm going to have func BA pointer receiver. This is important. Pointer receiver to bank account. I'm just going to call it deposit, and I need to pass in the amount that I want to deposit. It's not going to return anything. Now I'm going to do BA.balance. Can't spell balance. Holy crap, I can't type today. And I'm going to use a little plus equals operator to both set BA the balance on our bank account equal to itself plus the amount. In case you're not aware, this is the same thing as me saying BA.balance equals BA.balance plus amount. It's a shorthand for that. And lastly, we want to be able to withdraw. Now this one's going to have some logic to it probably, because we're going to say for our example that you cannot withdraw from the account if the balance in the account is insufficient, meaning if you're trying to withdraw 50 bucks and the account only has 30 bucks, it goes, sorry, I can't do it. So before we do that, I'm actually going to define that error up here by itself so we can read it. I'm going to say error insufficient, I don't know if I spelled that right, balance equals errors.new, and it's just going to say insufficient balance, like that. And so we're going to go to func BA bank account withdraw amount float 64. And it's going to return a float 64 and an error. What it's going to be returning is if the withdrawal is successful, it's going to return the new balance after the money is taken out. And technically, you could have done that with deposit too, but just for the sake of this, I'm not going to do that. And it's going to return an error if, in our case, for example, the balance is insufficient. So we're going to do if ba.balance is less than the amount, I'm going to return 0 and error insufficient balance. Otherwise, we're going to do ba.balance minus equals amount, which is the same thing as the plus equals, but subtracting instead of adding. And I'm going to return ba.balance nil, like that. So we now have our bank account. So let's interact with it to see what we can do. So I'm going to say A1 equal bank account Bob. Oops, that's the wrong thing. Okay. Bob owns it. Hi, Bob. And his balance is 50 bucks. That's not how you spell account. There we go. Okay. So let's deposit some money in his account. We're going to say A1 dot deposit, and we'll give him 20 bucks. You're welcome, Bob. And I'm going to print his balance afterwards. So we're going to say new balance, and it's going to equal to A1 dot balance. So again, we don't need to call balance here because we're still in the same package, but if you were to say import this code, this is how you would have to interact with that to get that balance. So let me go to the main, and we see starts at 50, adds in 20, and we get our new balance of 7. The reason why these are pointer receivers on these methods is you can set a struct to have to be the receiver of a function like this by either value or pointer. If it's value, you basically get a copy of the type and its values that you can interact with. Because it's a copy, if you change something, it doesn't actually affect the thing that you called it on. Because again, it's a copy. But if it's a pointer, it's actually going to be changing the original instance that you called it from. This is why balance just has value, whereas deposit and withdrawal have a pointer receiver, because they are mutating our bank account. If I had set this to a value receiver and I do amount, this actually won't change our original bank account's value at all. It just changes the value of the copy we have within the scope of this function, which is not what we want. Okay, so we have our basic bank account, okay? Let's say we have a new type of bank account we want to work with. And this is one that allows us to actually overdraft the account. And usually when you overdraft it, it's a fee. So you can do something in Go called embedding. which is when you have a struct that is embedded within another struct. And what this allows you to do is, we'll call the one that has a struct embedded into it the parent. The parent struct will have access to the properties and the methods attached to the embedded struct. So I'm going to have type, I call it, you can probably think of better names for this, by the way, but I'm going to call it overdraftable bank account. Yeah, nice verbose name there, huh? And it's a struct. And to embed the bank account struct to essentially give this overdraftable bank account struct access to the same properties and methods, you just put it in here like this. And I'm also going to say this has its own property called fee float 64. That's because if there is an overdraft that occurs, we want to know how much to tack onto their balance in addition to whatever its deficit is at the time. Now, since this has the bank account embedded into it, we can actually call all the same things that the bank account struct has from the overdraftable bank account. So I'm going to have A2 equals overdraftable bank account, like that. And now since the first argument is another struct, you actually have to pass in a struct for it. Like you could either pass in a struct you've already created, or you can create one here. So I'm going to do bank account. Jill, Jill owns this account, and her balance is 100. And the fee for this account, if it gets overdrafted, is $20. Yeah, ouch, $20. And you'll see that we can do the same things. I'm going to do A2 dot deposit $30, and do FMT print line balance for Jill A2 dot balance. So you remember we didn't define a deposit or a balance method on our overdraftable bank account. But if I run this, you will see that it worked just fine. It allowed us to access the properties and the methods on our embedded struct. Now we want the overdraftable bank account to have a different behavior when withdrawal happens. So right now, if we call withdraw on overdraftable bank account, it's just going to use the same logic from bank account. In order to give it its own logic, we have to essentially redefine withdrawal. So we're going to do func OBA, overdraftable bank account. Yeah. Overdraftable bank account withdraw amount float 64. That's basically the signature is the same, but the logic's going to be. So for this one, I'm going to start by defining an error that we're going to be returning at the end of it. Now this time, if the balance is less than the amount, we still want the amount to be subtracted, but we're also going to have to subtract the overdraft fee. So I'm going to do if OBA.balance is less than or equal the amount, we're going to do OBA.balance minus equals OBA.fee. And I'm going to create a new error up here called error overdraft incurred. Yeah. And errors.new overdraft incurred. You can have a more helpful error message. And I'm going to set error equal to error overdraft incurred, just like that. And then I'm going to do OBA.balance minus equals the amount. And I'm going to return OBA.balance and our error. So what will happen is if we call this with an amount greater than what we wanted or what's available, it's still going to give us back our balance, but the balance is going to be negative, and we're going to have an error here equal to this overdraft incurred message. We're going to make use of this error message later. So now if I go down here, how much does Jill have now? 130. So I'm going to do balance error equals A2 dot withdraw $150. And she ain't got $150. So what's going to happen is I'm going to do if error is not equal nil, log dot print f. Yeah, I'm going to say overdraft incurred balance is now %.2f. That's right. Yeah, and it's going to equal to balance like that. And so if we run this, it's going to say, oop, overdraft incurred. Your balance is now negative 40. Now, if you're not following, you may be, wait, why is it negative 40? Or we only took out 20 more than what we had. We'll recall there's an overdraft fee. Don't you love those? I'm not a stranger to those. I used to be, or I used to not be a stranger to those, but I'm a little smarter about money. So when this overdraft occurred, it actually took off the fee too. So now our account is even further in that than it was before. Great. Okay, so and just to show you that this is different behavior than the other one, if I do balance error equals A1 dot withdraw, and I do try to do the same thing, this one is actually going to give us a different message. Oh, actually, something else I probably should have checked too is I could have done instead of doing balance. Let me just here, because it's gonna yell at me. I don't actually want that. I'm gonna call a2 dot balance. I just actually want to show you that that balance is actually different now. Let me get rid of that. So run this, define oh, I say. See, it's still the balance on the actual struct now is indeed negative. So let me put this back now. Now, if I check this one is actually going to not have its balance change because this one wouldn't let you overdraft. I'm gonna do log.printf. We'll say balance %.2f and a1 dot balance like that. If I run this, balance, see, that one didn't let us do it at all. Now, when you have this embedded struct, technically speaking, you can actually still access the withdraw method on the embedded struct if the top level struct has the same method defined on it by doing like a2.bank account withdraw like that. If you specifically want that version of it, but you probably don't really want that behavior, I imagine, a lot of the times. So we have our two versions of a bank account now, and I'm going to show you a thing that you can normally do in object-oriented language, but you can't do it in Go. So I'm going to define a func here that I'm just going to call transfer. And transfer, it has three arguments. It has a debtor, aka somebody that owes money, and I'm just going to say it's a bank account, and a creditor, which is somebody that's owed money, and it's going to be another bank account, and then the amount, which is a float 64, and it's going to return a error maybe. So initially, I'm not actually going to implement this because I want to show you what you can't do in Go. So if we go down here and let me see, I'm gonna put money back in A2's account because I need to actually have a balance in there to make use of this next part. So normally in an object-oriented language, what you can do is something like, I'm gonna do error equals transfer A1, A2, and $50 the other word. See, normally you would be able to do this, but I believe you will not be able to do this. So let me run this, and you will see it says cannot use type overdraftable bank account as type bank account. Now in other object-oriented languages, this is called inheritance. You would be able to pass in a type that inherits from another type if you said the argument was the inherited type. But you can't do that in Go. So what you have to do is instead of using inheritance, you have to use composition, aka you have to use interfaces. And we're actually going to do that right now. So instead of saying that these two things are bank accounts that you want to withdraw and deposit from, let's look at our two types. Well, what are we wanting them to do, and what behavior do they share? Well, both of these types can have money deposited into them, and they can both have money withdrawn from them. So let's actually just encapsulate that concept into interfaces. So I'm going to go back up here, and I am going to declare two interfaces. I'm going to have type depositable, which is an interface, and it describes a method called deposit that takes in a float, which is, you'll recognize is the same method signature as our as the ones on our structs. And then we have type withdrawable, which is an interface, and that's going to have withdraw, taking in a float 64 and returning a float 64 and an error. And so if we go back down to our transfer method now, transfer function, instead of saying bank account, well, the debtor just needs to be able to have the money withdrawn out of it, and the creditor just needs to be able to have money put into it. So I'm going to say that this is now withdrawable, and that this one is depositable. Now we can actually use these in here because both of these types, both of these structs that we've created, implement both of those interfaces. So this allows us to, I can either have A1 or A2 be the first argument. Same thing with the second argument. And so let's actually do that now and see what we can do with it. Changing this, okay. So I'm going to say balance error equals debtor.withdraw the amount. That. And now we're going to actually make use of those errors. So if you recall, the regular bank account, if you try to withdraw when you don't have the money, is going to return a insufficient balance error. But in the case of the other bank account, it's going to return a overdraft incurred error. And if it was the insufficient balance one, that we don't want this transfer to actually take place, and we want it to stop early and return an error. But if it's the other type, we want to say just log that this happened, probably so that we can notify the person who owns that account that, hey, we had to overdraft your account, you had a fee incurred, you owe us money, but still complete the entire transfer. So I'm going to switch on the error. This. And if the case that it is an error insufficient balance, that we are going to just return error. and not actually finish this. If it's the case of error overdraft occurred, we are going to do log.printf of debtor incurred overdraft. New balance is %.2f balance. And then, but in that case, we're not returning because we can still complete the transfer. And we're going to do creditor.deposit the amount. And then return nil because there was no error in that case. So right now, let me just make sure I know what I'm actually messing with. So I'm going to do fmt, let me get rid of that real fast. fmt.println count one balance a1.balance, then count two balance a2 balance, like that, just so I actually know what I'm messing with. So count one has a balance of 70, count two has a balance of 60. So remember, account one is a regular bank account, account two is an overdraftable bank account. So I'm going to do error equals transfer A1 to A2, and I'm going to say 100. What this is doing is trying to take $100 out of A1's account and put it in A2's account. Now, because A1 is a regular bank account, this is going to return an error. So I'm going to do if error does not equal nil. Typing is going crazy. If error does not equal nil, log dot fatal. Like this is all screwed up now. Log dot fatal, or I'll do fatal. We'll do the we still want to do the second example. We'll do log dot print f could, that's not spell could not complete thank you, transfer %b, and that's going to return the error. So if I run this now, you're going to see, whoops. Oh, right, sorry. This is the other thing I should have mentioned. So when the receiver of the method is a type, is a pointer receiver, whenever you're calling those methods, these actually have to be pointers. Otherwise, those aren't going to work. And if I run this, you'll see could not complete transfer, insufficient balance. That's the behavior we expected because A1 does not allow overdrafts. But now if we do error equals transfer A2 to A1 of 100, if error does not equal nil, we're good to just do the same thing, log.printf. That makes sense. Copy this. Yeah, like that. Now, if I run this, we should not see that message twice. Yeah. But we did see the message, debtor incurred overdraft, new balances minus 60. So that actually worked. And just to make sure that it actually did the deposit part, let's do fmt.println of account one balance a1 balance. So if this completed successfully, the first account should now have $170 into it. Run. That's yep. So the debtor got its overdraft slapped on it, and account one now has $170 in it. Yay! Sucks for account two though. And in terms of object-oriented programming, that's kind of a simple example you can do here. There are more comprehensive and more complex examples of people doing like more OOP approaches where you say instead of this type being exported, you actually don't even export the type, so they can't create their own instances of it, and you have like a do function that is a replacement for a constructor that normal object-oriented programming languages we have. But I don't really like even doing that. Like, I know there's probably good cases and good reasons for taking a more hard line object oriented programming approach in Go, but fundamentally, Go is not an object oriented language. And sometimes when I see people do that, it feels like they're trying to shove a square peg in a round hole. You know what I mean? Like, you're trying to solve a problem in Go with an approach that Go doesn't really fully support, and it means you're not really designing your solution in a way that's conducive with the language features and the way that the language is designed itself. That's just my 2 cents. Hope this all made sense. It's kind of weird to explain OOP and Go because it doesn't like fully support object oriented programming, but it does something close to it. Uh, if you like the video, be sure to like, subscribe, whatever the vernacular is, or wherever you're watching this. Be sure to share the video if it helped you. If any of this like was just kind of confusing and not didn't make a lot of sense, you can ask. You can leave a comment down below, and I'll do my best to explain more if some of this didn't make any sense. And with that being said, y'all come on back now, and I'll see you next time.